Man-woman collaboration. I'm interested in collaboration from many dimensions. International, no collaboration like solo research, but also men-woman collaboration in relation to careers. We have a study of all university professors who are internationally visible, like 25,000. But by way of introduction, well, we all know that science is collaborative enterprise, not in social sciences, but more and more so, not in humanities, more than 50% of solo research, but generally science is collaborative. And while we all collaborate internationally or nationally or institutionally, or we don't collaborate at all, this is not my topic today. I'm going to be talking about collaboration across genders, which is much more rare. I'm interested in all male or all female and mixed sex collaborations. So can be international, national, or whatever, but I'm interested in collaborating across genders. What is the view in literature? What literature says that on average, globally, which means basically in Anglo-Saxon countries, as we know, men collaborate more often with men, and women collaborate more often with women. And this is a very general global picture. And I'm testing this hypothesis using a huge or large-scale data set and new variables. The new variables, which have not been used so far, are biological age of every of these 25,000 university professors and academic positions and biological age. I'm not using academic age, which is just a proxy. I'm using biological age. We all make decisions in science. Decisions are, well, do we work in teams or do we publish solo? Do we work in same-sex or mixed-sex collaborations? Do we collaborate locally or nationally or internationally? And all those decisions involve some inequalities in science. We know the consequences, for instance, consequences in terms of citations or in terms of impact. We know there are differences in impact between men and women. For instance, for men, the best choice in terms of citations is to collaborate internationally and to work in mixed sex teams. But for women, mixed sex papers hardly increase chances for tenure. And we know it from US studies. So there are different conditions for different genders, so to speak. The decisions differ by age, by position, by discipline, but most of all, the consequences of these decisions differ by gender. So finally, authorship decisions, whatever we decide, are consequential for our careers, for academic careers. And also decisions accumulate over time. They finally go to our CVs. It's not only a list of publications, but also impact, also citations, also networks in which we are, like grants together with colleagues. So generally, our authorship decisions or collaboration decisions accumulate over time. I'm interested, you see on those pictures on the right, guys, males and females, men and women. And I'm interested in homophily, in this principle, quote, similarity breeds connection. When I say homogeneous or heterogeneous networks, I mean same-sex and mixed-sex research publishing teams. It's a proxy, obviously. Publishing is not all of collaboration, but it's some of collaboration, and it is more easily traceable than other kinds of collaboration. So papers, authors, authorships, treated here as collaboration, which is obviously just part of the picture. There are positive and negative consequences of homophily in science. On the positive side, homophily in science simplifies communication, enhances predictability of behavior, etc., etc. It's been studied for no, we are here, just one word. I told you about it. So we make decisions all the time, and in a word, decisions, collaborative decisions we make are consequential for our careers. That was more or less the story. And the authorship decisions accumulate over time. They go to lists of our collaborators, they go to our CVs in terms of publications, etc., etc. Okay, this was the story. And next slide, please.
Yeah.
Okay, I told you about the homophily in science, which means men collaborating with men and women collaborating with women. And the story was that there are positive and negative sides of this homophily. But negative side, just one word, homophily or men-men collaboration, women-women collaboration limits people's social worlds. So we live in different worlds because information received is different. Attitudes we form is different. Our interactions are different. So homophily matters because the science is increasingly collaborative today. And the next slide, please. Yes, very briefly, networks matter. It's not only publishing, it's also being in a network or in the networks. So only if we are in networks, our impact is big. So far, literature has been showing that female scientists mostly collaborate with female scientists, which is called female ghettos quite often. And just one more word, and I have to speed up a bit. Team formation in this case is publishing with co-authors, and importantly, it's voluntary. We collaborate as we wish, with whom we wish. Generally, it's voluntary. We decide whether we are better off collaborating or publishing alone, and this is just a choice. Okay, the final sentence is, we need to remember that women generally in literature, mostly Anglo-Saxon literature, when women collaborate with women mostly or operate in women circles or networks, are at a disadvantage. And this is important for academic careers. Okay, next slide, please. Yes, you see the the clubs on the left, and generally the darker side of the gender context. We know all those details. I'm not going to discuss it, but what I want to stress is that times are changing. We believe from literature that women receive less grant money or are promoted more slowly. There are 3 decades of studies showing this, but what I'm stressing is that the times are changing, slowly but changing. And there are newer studies which show smaller differences in salaries or smaller differences in senior positions, etc., etc. So there is a dark side of the gender context, but still times are changing. And next line, please. Next slide, please. Very briefly about Polish case and women in science in Poland. We have a very high proportion of full professors compared to OECD countries. 30% of full professors are women, and there are 10 disciplines, interestingly, in which there are more female participants, female scientists than male. And these are not only social sciences or humanities, not only business or economics, but for instance, chemistry or biochemistry or agriculture and biological sciences. So we are, as a Polish system, we are a gender balanced system as opposed to many OECD systems. So 50% or more women are present in those disciplines which you see here. And then next slide, please, Matthias. Yeah, just one word because we don't have enough time. Gender gap in science classified. I did a classification based on 2 or 3 decades of research, and we clearly can distinguish between input related gaps and output related gaps. Just to give an example, self-citation gap is input related. If men overcite themselves or self-cite more, on the input side, they create a gender gap. But if we look on the right, output related gender gaps, and example, gender citation gap, it's not dependent on the offer, it's independent. Also group recognition is independent. Also tenure decisions or gender tenure gap is independent of the offer. Also gender salary gap. So we have input gaps at the level of publications and other dimensions, and with output gender gaps. In total, there are at least 16 gender gaps at the moment. This is the minimum. I studied with my colleague gender solo research gap recently, like a month ago in Saintometrics, solo research gap. So there are gaps or differences or biases depending on the context everywhere. And next slide, please. Just for examples, large scale man-woman collaboration on the left, then solo research gap on the right, and finally the gap in international and institutional collaboration in different journals in the past 2 years. So men versus women. In each case, we studied individual publication portfolios of every university professor. I will explain it in a moment. Next slide, please. How we differ. I mean, myself and Dr. Wojciech Roszka, co-author of this research. We examined every internationally publishing Polish male and female scientist, everyone who in the past decade had any publication in Scopus. We had all 100% gender determination. It's important because we often use gender classifying or gender defining software. In our case, we had all 100% gender determination. We produced what we termed individual publication portfolios for every Polish scientist, just to study this same-sex collaboration ratio or homophily ratio, which the story is about. And finally, perhaps most importantly, we use as a unit of analysis individual scientists. I'm working in the tradition of academic careers and academic profession studies. I'm not working in the tradition of bibliometrics. So my unit of analysis is scientist and not individual publication. You see on the right, this is person, not publication. And next slide, please. This is how we constructed a database, just 2 or 3 sentences. We had 2 databases, a national registry with 100,000 scientists and Scopus database with 400,000 publications. And we used probabilistic record linkage, deterministic record linkage to arrive finally at the bottom at what we termed the Polish Science Observatory database. And this is the database we are using. Next slide, please. Yes, just one definition for you, which is on the left among descriptions. We are studying same-sex collaboration ratio, or this homophily ratio. And it means the percentage of same-sex collaboration articles, male, female, among all collaborative articles in an individual publication portfolio defined for a decade. This is the only important thing from these variables and from this hypothesis, how we define this same-sex collaboration ratio. It's just the number of same-sex publications divided by the number of all collaborative publications within this decade. And the next slide, please. The sample is slightly more than 25,000 scientists. You can see the distribution, age distribution on the left. You see that females are disappearing around 60 when they are around 60. So you see that female participation decreases with age, more or less. The underrepresentation of females is just in 4 areas, including certainly computer science, engineering, and physics. Next slide, please. There is a number of simplifying assumptions. I'm not going to discuss them. I'm just mentioning that there are these assumptions. For instance, Scopus, we use journal percentile ranks provided by Scopus as if they were stable for a decade, even though they fluctuate. So there's a number of limitations which I'm frankly describing here. And next slide, please. We have the results now and the conclusions and some implications. Same-sex collaboration and gender. We were expecting, reading literature, that women would be collaborating much more often with women, but it's not the case. Our findings do not support this this pattern for women, and this is surprising. But let us remember, 90% of literature in the past 3 decades comes from Anglo-Saxon countries, which is specific case. Again, on the global scale, it's just a specific case. So what is the result? If you look on the left, for male, the median same-sex collaboration ratio for male is 0.5. The range is from 0 to 1. I explain it on the right. If males collaborate only with males in all publications, the ratio is 1. And if males never collaborate with males in all publications, the ratio is 0. So the range is from 0 to 1. And you immediately see in this data that men have 0.5 rate, while women have only 0.15, which means basically that women, at the first approximation, do not collaborate with women as much as they could be. And next slide, please. We studied these collaboration patterns not only by gender in general, but also by age groups. So if you look at the left, you have this ratio from 0 to 1, and you have gender in colors, different colors. And when you look at female scientists on the right with my red circles, you can see that females at any age, in both young age group, middle age group, and older age group, don't collaborate as much as men with women. So male scientists tend to collaborate with male scientists, and you can see it, but female scientists tend not to collaborate with other female scientists. You see all those bigger bottoms around 0. So the big bottoms for females mean they do not collaborate with other females because it's close to 0. So this finding is absolutely not in line with previous research. Women are expected to be working with women, but they are not. And my comment is, let us remember that the Polish system is relatively gender balanced. We are not talking about a system in which there is massive amount of men and small number of women. This is not the case. Half of the scientific population are women, and it goes by age. It goes also somehow by academic positions. Let us move to the next slide, please. We studied academic positions, and the results are similar. If you look at women on the right, the blue color, and you want to compare ones with zeros, you can see that ones are very small. So women are not collaborating with women. Women are collaborating with men. That's why the homophily rate or same-sex collaboration rate is close to 0. So you see the picture across age groups is similar to the picture across academic positions. We know they are highly correlated, but still they are different. And I'm showing these pictures separately here. And the next slide, please. We had a distribution and we saw the medians, but also we can see only the medians of this rate, which I'm interested in, the same-sex collaboration rate. And you can see it immediately. The yellow color is for females and the orange color is for males. You can see, let's look at young people on the left. The collaboration rate for young females is like 0.06, very rare case. And for males, it's 0.54, and it goes across all ages. You see the pattern. Everyone in general wants to collaborate with men. I will try to explain in a moment why. And the next slide, please. We are slowly coming to an end. Yes, we also studied this same-sex collaboration rate on a year-by-year approach, and you see opposing trends. You see that male scientists generally have a very high homophily ratio. very high, right? From 0.75 to 0.5 in general. And female have very small homophily ratio or same-sex collaboration ratio. And this is perhaps the most telling picture. No matter which age you take, from 30 to 70, the picture is pretty similar. Young women tend not to collaborate with women, and older women still tend to collaborate primarily with men, even though there are changes, and you can see this trend going up. Every dot represents the median value of the same-sex collaboration ratio for a given age, like 30 years old, 31 years old, etc., etc. And next slide, please. When you ask me about the disciplines, we discuss it in detail. Are there any differences between male-dominated disciplines, and they are on the right in this picture, and female-dominated disciplines, which are on the left? There's a number of disciplines which are also right in the middle, with 50% participation, like humanities, social sciences, economics, business, chemistry, or environment. No matter where we look, we see that the differences is not so much related to male or female domination. You can compare, for instance, computing and physics with huge male domination with biology or pharmacy dominated by females. And you look at same-sex collaboration ratio, it's more or less the same. So the ratio, same-sex collaboration ratio, homophily ratio, does not depend so much on the presence of males and presence of females in a given discipline, which was a major issue. You see that this regression lines is moving up slowly. The R-squared is 0.05, so there is some trend, but it's not powerful. And next slide, please. There are 2 or 3 more only. We're measuring journal prestige, and we are seeing to what extent publications written in different combinations, like male-male, female-female, or mixed, or solo, to what extent they go to different journals. It's relatively easy to measure for every person. And then we aggregated the data to men and women in different combinations. So as I told you, everyone has a unique individual publication portfolios. We calculated the Scopus journal percentile rank for every publication, and we constructed average prestige measure for everyone. And you will see the details in the next slide, please. And in the slide, you can see that publications written in the mixed sex collaboration go on average, and we are talking about, well, 160,000 publications in total. They go to, so to speak, more prestigious journals than publications written in same-sex collaboration. And then both of them go to much better journals than solo research. It's absolutely clear that solo research written by females, which is yellow color, these publications go to the least prestigious journals of all. And wherever there are mixed combinations, male, female, and related, these publications go to, so to speak, more prestigious journals. And we have thousands of publications, and we have aggregated data. So this is the Polish case. We studied all disciplines combined, which is this case, but we also did calculations by discipline. The pattern is more or less the same. And now, next slide, please. The final slide with the data, I believe, and with some useful information. We studied different institutional types. So we were comparing research-intensive institutions with all the rest of the system. And it looks like, speaking about these 25,000 university professors, that homophily increases for males in research-intensive settings. So males or men are collaborating more with men in research-intensive universities, and females female scientists are collaborating more with males also in these research-intensive institutions. So homophily is stronger for men. Gender homophily in research-intensive institutions is stronger for men and weaker for women than in the rest of the system. This is surprising, but it shows to what extent research intensity drives homophily in those stronger institutions in terms of research. Men collaborate with men even more intensely, and also women collaborate with men more intensely. This was surprising. And just one sentence, which is the last point, analyzing the OECD context right now. This is true. We are doing a large case study on 38 OECD economists based on those patterns which we have seen here with reference to Poland. We have almost all data except for biological age, certainly, but we use the proxy of academic age. And we basically know we have to use it for STEM areas mostly or only. And also we don't have positions, academic positions, but we can use age group seniority defined by age groups like beginning, middle, older, and the oldest every 10 years or so. So it's possible. We are doing a parallel study for the OECD area. Finally, its conclusions, I believe. Next slide, please. Oh yeah, just one sentence. We also did fractional Logit regression models, but the finding was as follows: being male and working in male-dominated discipline are the two most influential predictors of the same-sex collaboration ratio. And the next predictor is working in a research-intensive university. More or less, results from modeling approaches were parallel to findings with these two-dimension analysis, which I described a moment ago. This Logit regression model is enormously useful because it applies to those ranges between 0 and 1. Whenever we have 0, 1 as a range, this type of regression works perfect. And the last slide is final words or conclusions. We tested the homophily principle. So we tested similarity in Poland in publishing and whether it breeds connection or not. Yes, it does. But in the Polish case, homophily principle works only for male scientists. It doesn't work for female scientists at all. Both men and women collaborate massively with men. And this is a difference from global patterns. Globally, we know from the literature and from the data provided that homophily is strong. Male-male, female-female collaborations are important. It's not the Polish case, and we're wondering why. Is it legacy of communism, or is it type of society which is still patriarchic, or are the social norms in academia? I would say all of them matter, even though it would have to be taken care of by survey or by interviews. Finally, it's good, I would say, as is, because if Polish scientists, if Polish young women or young women scientists do not collaborate excessively with women, all those gaps described for globally may not work so powerfully. So the as-is situation contributes perhaps to the reduction of the gender productivity gap, because the consortia in which females produce are different. Citation gaps may be smaller. Promotion gaps may be smaller because of these different patterns. Why? Because these gaps may widen, and we know they do widen if women excessively co-author with other women. We know that female-only networks are less powerful, and there are implications for those female ghettos, which are not present in Poland. So we are different, the patterns are different, but let us remember that most patterns found so far come from the US, UK, or Australia. So there's a limited, very limited knowledge base about male-female collaboration so far. This is an example from Poland. We did it some time ago, and we work on the OECD patterns like global academic profession and global patterns, males, females, or male-male, female-female collaborations. Okay, that will be all. Thank you so much.